Hello everybody, welcome to my YouTube channel. I am the Calc Wizard, and this channel is going to try to help you guys understand the principles of calculus better. So today we're going to be going over the chain rule of calculus, and how I like to describe the chain rule is we take the derivative of an outer function, keeping the inside function the same, and then multiplying it by the derivative of the outer function, or the inner function, sorry. So if we have this textbook example, h of x equaling f of g of x, we're going to take the derivative. We're going to try to find h prime of x. We're going to take the derivative of the outer function, leaving the inner function the same, multiplied by the inner function's derivative, so g prime of x. Okay, so that's kind of like the textbook example of how you do derivatives when we need to do a chain rule. So we're going to do other examples. We're going to have g of x equaling a cosine of x cubed minus 2x. Okay, we're going to have to determine our inner and outer functions because we can see that this is going to be a chain rule. So our inner function is going to be this stuff inside the cosine. So it's going to be x cubed minus 2x. Our outer function is going to be this cosine of stuff. And that's how I like to do the chain rule. I like to say a function of stuff and then multiplied by the derivative of stuff. So if we want to find g prime of x, we're going to have to take the derivative of the outer function. And these are not negatives. This is just denoting that what the inner and outer functions are. So we're going to take the derivative of cosine, which in this case is negative sine. We're going to keep the inside of the same, that stuff the same. So it's x cubed minus 2x, multiplied by the derivative of the inside, the inner. So that would be 3x squared minus 2. So that's kind of an easier problem when we're doing the chain rule. And it's kind of easy to determine the inner and outer functions. We're going to do more examples here. We're going to have y equaling to x to the 5th minus 2x squared minus 3, all cubed. Okay, we're going to have to determine our inner and outer functions first because we can see it. This is going to be a chain rule problem. So our inner function is going to be this x to the 5th minus 2x squared minus 3. And our outer function is going to be our stuff on the inside, all cubed, okay? So if we want to get y prime, we're going to first have to take the derivative of our outer stuff. Okay, so that's going to be 3 times our stuff inside, squared, times the derivative of our our inner. So it'll be our stuff, it's derivative, okay? So then we're going to take our inner stuff right here, x to the 5th minus 2x squared minus 3, all squared, times the derivative of that inner stuff, which is 5x to the 4th minus 4x. Okay, so that's a better example, or not a better example, but another example of doing the chain rule when determining our inner and outer functions. With using this notation, which I like to use, which is stuff. So we're going to do one last example here. We're going to take our f of x equaling to e to the x squared. So I'm going to let you guys pause the video, try to determine what our inner and outer functions are. So our inner function is going to be our x squared. Our outer function is going to be e to the stuff. Okay, we're going to have to find f prime of x. So the derivative of e to the stuff, which is our outer function, the derivative of e to the stuff is just e to the stuff. If you know calculus, the derivative of e to the x is just e to the x. So we're going to take this, e to the x squared, all times the derivative of the inner function, which it would be 2x. We're going to clean this up. We get 2x e to the x squared. So that's kind of how you do the chain rule, or how I like to do the chain rule. I hope this video helped you guys. And if you have any questions or comments, please leave them in the comment section below. Don't forget to like and subscribe to my channel. And if you guys have any future principles of calculus that you want me to go over, please leave them in the comment section below. Thank you.